Quadratics! Alright, episode 3. Little flash forward for you. We are, for now, skipping LT3. And we did LT4 in class. So what we're talking about now is LT5. The reason we're skipping, just real quick, the reason we're skipping LT3 is LT3 talks about how to choose the best way to solve a quadratic. And we don't really know the best way to choose because we don't really know how to solve them. We saw one way on Monday, but the others we've not touched on yet, so we can't really choose between them. Here's some just quick definitions for you. Expanded form. This is what you get after doing FOIL and then simplifying. So if you remember all the way back to the beginning of the year, we might have had something like that. And we would use FOIL or distributive property to simplify this. The expanded form is basically what you get after doing the expand and simplify, or the FOIL and simplify. And we also, in episode 2, saw this as general form. So those are kind of the same thing. Here, again, is just a little reminder of what general form looks like. This y equals ax squared plus bx plus c. Factored form, we also saw that in episode 2. Looks like that. This video is going to be a lot about factored form, putting it into factored form. What do you do when it's in factored form? It makes it really easy to find the roots using something called the zero product property. And basically what the zero product property is, if you have two things multiplied together, a and b we'll call them, if you have a times b and that equals 0, if that's true, then either a has to be 0 or b has to be 0. So this could be like a, a times b equals 0, so a equals 0 and b equals 2 kind of thing, or b equals 0 and a equals something else. But that's basically what the zero product property says, and we will use that to find the roots. It'll be more obvious what this actually means and how you use it in just a minute. So example, solve each of these equations below for x. Zero product property says if a times b equals 0, then either a equals 0 or b equals 0. So if we're solving this, we can call this our a and this our b. So part 1 is if a equals 0, so if x minus 9 equals 0. Part 2 is if 3x plus 4 equals 0. So again, just kind of breaking it down. We've got our two parts, a and b. Here's b. Here's a. And one of them has to be 0. So we're going to find what value of x makes this 0. Well, that would be 9. 9 minus 9 is 0, so x equals 9. Over here, we get x equals a negative 4/3. So our answer to this would be x equals, for this expression on the left side to equal 0, x has to either equal 9 or it has to equal negative 4/3. So we really sort of have two answers. This next one is actually just not a quadratic. We're going to practice just the solving for x part. But if you expanded this all out, you'd end up with a cube term. So just a little side note for you, this is not a quadratic. But we're actually going to have 3 parts in this one. We're going to have part 1, part 2, and then part 3. Part 1 is pretty easy. 4x equals 0, so x equals 0. Part 2, x plus 6 equals 0, so x equals negative 6. Remember, again, I'm looking for what x value is going to make this left side equal 0. Part 3, 4x minus 9 equals 0. We end up with x equals 9/4. So our answer, x equals 0 or negative 4/3 or, no, that was from the last one, sorry, or negative 6, or x equals negative 6, or x equals 9/4. When you look at the factored form, it kind of breaks it into the different parts for you, and then all you're looking for is the case where each one would be 0. What x value do I have to plug in to make each part 0? That's pretty much what the zero product property says. The reason that we've been talking about all this 0 stuff, if you look at the next part, it says solve it for when y equals 0. Remember we talked about the graph, and on the graph of a parabola, when y equals 0, it gives us the x-intercepts. We also call these the roots. We also call them the zeros. And this, hopefully, makes that zeros part fairly obvious. When you plug in y equals 0, you're finding the zeros, same as the roots, same as the x-intercepts. So the first step that we have to do for all of these is to plug in a y equals 0. I'm just going to go ahead and do that for all of them. So I've got my my 0 plugged in for y. And next we are going to factor it. This is factoring is just the exact opposite of FOIL. Okay? So FOIL would take things and expand it out of factored form. Factoring is the exact opposite. It's going to take something from general form and put it into factored form. And the way we do that, there are basically a couple things that we need to look for. We need to first look at the constant term. And I'm going to start with this one first just because this one is actually probably going to be one of the simpler ones. In order to factor it, we're looking first at the constant term, and I'm looking for the factors of the constant. So in this case, the factors of 25. And I could do, if I make a little factor tree, I could do 1 and 25, or I could do 5 and 5. And those are all the factors. So I'm either looking at 1 and 25 or 5 and 5. The next part I need to look for is the coefficient on the x term, not the x squared, the x term. And I need to look for which of the factors add up to 10. So I'm going to pick 1 and 25. Obviously 1 plus 25 is not 10. 5 and 5, hey, 5 plus 5 is 10. So the factors that I need to choose then are 5 and 5. So the way that I will write this out then is x plus 5 times x plus 5 equals 0. Okay, that's factored form. I found my two factors based on the factors of 25 as part 1. Whoops. As part 1. And part 2, I looked for which factors add up to the coefficient of x. And I figured out that my factors were positive 5 and positive 5. And so that gave me this x plus 5 times x plus 5. All right, now on to actually solving it. Using the zero product property, I know that x plus 5 has to equal 0, or x plus 5 equals 0. So I just took the both parts, which in this case just happen to be the same. So I get x equals, in order for this to be true, negative 5. Solve it for x equals negative 5. So my answer is x equals negative 5. In this case, there's only one because the factors were the same. So my answer, x equals negative 5. Let's move over to the bottom right one here. I need to first find what my two factors are going to be. So I'm looking at negative 42 as my constant. Now this can be negative 6 times 7, or, let me move this down, or it could be negative 7 times 6, or it could be 21 times 2, or negative 21 times 2, or what else could it be? It could be 3, or negative 3 and 14, or the other way around, it could be negative 14, 3. So this one I have a ton of different options. The number that I need to pay attention to in order to figure out which one of these it is, I need to look at this positive 11. So which of these factors, pairs of factors, adds to positive 11? The 6s and the 7s won't. The 21 and the, well, that should have been a negative 21, but irregardless it won't. That one won't either. This gives me a negative 11. This gives me a positive 11. So my factors are going to be 14 and negative 3. So I'm going to get x plus 14, x minus 3 because it was a negative 3. Now we're just down to the easy part. X plus 14 equals 0, or x minus 3 equals 0, x equals negative 14, or x equals 3. And that is my answer. In terms of the graph, that means that the x-intercepts are at negative 14 and at 3. Over here on our first one, if it only has one x-intercept, we talked about this last week, this would mean that the vertex is actually at x equals negative 5, since it only has one. Up to the top, there's going to be one little extra step here before we factor it. You know what? Actually, cross off this example. I don't even like that. We're not even going to do that. Over here, in our first one, this is just a little bit tricky because we don't have a part 1, like we don't have a constant on here. So our part 1, I guess, if you want to call it that, or our constant, would really just be a 0. And so the factors of 0 are 0 and like anything. So if you do this one just like you did on all these other previous ones, you would have an x plus 0 as one of your factors and an x something as your other one. Look at our part 2 here. We need our two factors to add up to negative 2. We know one of them is 0, so this one obviously has to be negative 2. Now this front part, x plus 0 is just x, So I'm just going to rewrite that as x times x minus 2, because we really don't need the 0. Then go to use zero product property. The first one I'm just going to get x equals 0. This second part here I'm going to get x equals 2. So my answer, x equals 0 or x equals negative 2. Okay. We got two, now let's do this second one. So we got 10 plus y equals x squared minus 3x. First thing I want to do is just replace y with 0. So this is going to be 10 plus 0. In order to factor this, I need to get everything over to the right side, so that means I just need to get this 10 out of there. And I get 0 equals x squared minus 3x minus 10. Then I need to factor it, so I'm going to look at the factors of negative 10. And I could have 1 and 10, 1 negative 10. I could have negative 1 and positive 10. I could have negative 2 and 5. I could have 2, negative 5. So part 2 is look for which pair of factors over here will give me negative 3 when I add them together. And that's going to be a positive 2 with a negative 5. So my factored form is x minus 5, x plus 2 equals 0. Then using zero product property, x minus 5 equals 0. X equals 5, x equals negative 2, and there's my answer. All right. If you want one more example of this, I'll do this one. Otherwise, you can skip ahead for a minute and a half or so and just go to the before class. First step, put in y equals 0. Then I'm looking for factors of 42. We wrote them down earlier. We wrote down like 1 and 42, 2 and 21. Let's see, we had 4 and 13. What else? 6 and 7. We could have 6 and 7. We could also, since this is a positive number, have negative 6 and negative 7. When we look at our second part, 6 plus 7 is positive 13, but negative 6 and negative 7 is negative 13. So those are my two factors, negative 6 and negative 7. Using zero product property, you get x equals 6 or x equals 7. Our roots are 6 and 7. Our zeros are 6 and 7. And our x-intercepts are 6 and 7, because again, those are all the same thing. Okay, so your before class, this first one gives it to you factored already. So all you're looking to do is find the zeros slash roots slash x-intercepts. So this you're just using zero product property. A hint on this second one: if you divide this whole left side by negative 3, this becomes a lot easier. So the first thing I would do is divide by negative 3. That gives you negative 6x plus x squared equals 0. And then hopefully from there you can kind of figure out what to do. It's just like one of the examples that we did over here on this page. And then this last one, you will have to get rid of the -6 over here so that you have a 0 and everything else on the left side first. Then factor it and find the zeros. Stay tuned for a little preview of the next episode of Last Graph Standing, brought to you by Anna.